To solve this trig equation, we're going to need to use identities and factoring to arrive at our solutions. So I'm going to start this problem by using some identities. Now you may notice right away we've got a problem with cosine and sine in it. So that's going to potentially be a problem, and this time it is. The identity that I'm going to use to help make everything cosine in this problem is I'm going to remember that the Pythagorean identities, there's something involving sine squared and cosine squared, and if we look at our identities chart, we're hopefully seeing that sine squared is equal to 1 minus cosine squared of theta. So I'm going to go ahead and use that identity to start this problem and replace the sine squared with 1 minus cosine squared of theta. And even though that's going to make the problem look slightly more complicated, it's actually good because I will only have cosines in the equation then. So if I rewrite the other side, 3 times the cosine of theta plus 3. So from here, let's go ahead and distribute the right-hand side. So I'll distribute the 2 to everything over here. So I would get then 2 minus 2 cosine squared of theta. And again, the other side I'll just leave as is for now, 3 times the cosine of theta plus 3. At this point, since I only have cosines in this, but I see that one of those is cosine squared, I'm going to need to use factoring to finish this problem. So, as we've always done when we solve by factoring, everything will need to be moved to one side. And since I want my squared term to be positive, I'm going to go ahead and select everything to move over to the left-hand side. So when I do that, I'll end up with a positive 2 cosine squared of theta. And remember, if it's easier to think of that as 2x squared, go ahead and think of it that way, especially when we get to factoring. This is the only cosine piece I have, or if you think of that as just x, it's the only x piece you have. So 3 cosine of theta. And then finally, when I go ahead and subtract 2 from both sides, I will have like terms. So I'll have just a positive 1 over there, and now equal to 0. And so at this point we're ready to factor it. Well, if it's easier to think of without the trig part of it, just think of this as 2x squared plus 3x and then plus 1. And so if you can factor that, you can factor the trig problem. So actually, let's go ahead and factor this. Since there's a 2 in front, we'll use the box method to factor this. Hopefully you're pros at this by this point. So I'll take my first term and put it in the first box, that's 2x squared, and the last term down there and multiply those together, that multiplies out to a 2. I need to finish filling out the 2 boxes with 2 numbers that multiply to 2 but add up to 3 right there in the middle. So that'll be 2 and 1, so it doesn't matter where you put those, but make sure they have x's on them. And then to finish it, we'll look across the rows and columns for greatest common factors to see what we get when we factor this. So those have an x in common, those have a 2x, and those have a 1 in common. And so that's what this factors into back with just x. If I replace those x's back with cosines, what they really were originally, I'd end up with this. 2 times the cosine of theta plus 1 instead of 2x plus 1. And then as a second set of parentheses, the cosine of theta plus 1 instead of x plus 1. So there's my 2 sets of parentheses, and so finally, oops, I got equals 0 there, sorry, out of space. Now that I have everything equal to 0 and factored, I'm ready to finish this equation. So I'll go ahead and separate this out, and I'll solve either side of my, or I'll solve, set both parentheses are equal to 0, and then solve those equations. So if I get the cosine by itself, I'd have the cosine of theta equals negative 1/2. I'll assume you're okay with those 2 steps I did in my head there. Using my chart then to finish this one, I can see that my reference angle that I'm looking for is going to be pi over 3, but I'm looking for that where the cosine is going to be negative, and so that's going to leave me in this quadrant over here, cosine is negative, and then in this quadrant down here, sorry, cosine is also negative. However you then want to find those 2 angles, this angle comes out to be 2 pi over 3 as one of our solutions. This angle comes out to be 4 pi over 3. So we got 2 solutions from this, sorry, over 3. So we got 2 solutions from this half of the equation. Let's see what the other half gets us. If I set that equal to 0, and solve it, I would have to subtract 1. Again, using my chart, if I want to look up to see what angles have a cosine of negative 1, there's only one of them, and that's an angle of pi. And so we end up, after all that work, with 3 total solutions, this one quadrantal angle and these 2 angles over here.